Hello, ladies and gentlemen. Root Beer here, looking at another Hypatia contest, the 11th grade written solution contest. And we're going to be looking at the Hypatia from 2006 in this video. As usual, I encourage you so much to click the first link in the description. Not for me, for you guys. Download a copy of this contest, print it out, use the 75 minutes that you're supposed to get, and practice this contest for yourself. That is the best way. I know I mentioned it a lot, but it is really the best way to prepare yourself for these contests. Practice makes perfect. Okay? So, with all that said, let's get into it with question number 1. Alright, so there's 4 questions on here. 75 minutes, as I say. Nice little Hypatia contest. And question number 1. The odd positive integers are arranged in rows in the triangular pattern as shown. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Okay. What is the 25th odd positive integer? That's a weird question to ask. In which row of the pattern will this integer appear? Okay, that's a little better. That ties it back to this question here. Okay, so for example, so we get 1, 3, and 5. So if we were talking about the eighth positive odd integer, that would be 1, 2, 3, 4, 5, 6, 7. So it'd be 15, and we should find some way to show that 15 is in the 4th row here. 25th. So I can pretty quickly determine what the 25th odd positive integer is. In what row of the pattern will this integer appear? Well, let's talk about the 25th positive integer. So our first positive integer. So all odd integers can be written like this. Okay. Now we want the first one to be 1, and if I plug in k equals 1, I'll get 3. So I'm actually going to rewrite them like this. I'm going to say this is the kth positive odd integer. So the 25th odd integer is 2 times 25 minus 1, 49. Now, can I quickly see where 49 should be? Not quite. So I noticed that we go 1, and then here's our 3rd, and then here's our 6th, and 19 is our 10th. Yeah, so the rows are increasing by 1 each time. And so the kth positive, I'm probably just going to start calling it the kth odd integer. Kth positive odd integer appears in the, nth row if so it's nth row if k is less than or equal to 1 plus 2 plus n, and k has to be greater than the same sum there. Yeah, so if k is between these two. That's what we're looking at here. Because you'll get 1, and then you'll get 2. So if you're going to be in the 3rd row, you have to be bigger than 1, 2. You have to be bigger than the 3rd odd integer. And then if you were to be in the 4th row, you have to be bigger than the 6th odd integer. And so your k has to be bigger than the sum of 1, 2, 3, the full number of in each row above you, all added up. Okay, so these numbers I recognize pretty quickly. These are triangular numbers. Why? Well, they form a triangle when you start writing them out, but they have a fairly well-known formula. The sum of the first n numbers is n times n plus 1 over 2, and with a grade 11 contest, I would feel comfortable using this without having to prove it. So k has to be in this particular range. Okay. Now, how does this help me for the 25th one? I mean, aren't we just adding more layers of difficulty? Yes and no. So you could just start listing. I mean, 25 isn't that long. You could start listing them out and say, oh, 49 is in the what'll it be? 7th row, I think. And you know, that would be fine. And if you want to list them all out, that counts as a proof. It really does. And it's 1A. Why are we making things more complicated? Because I have a feeling that with B and C, we're going to need to know a little bit more about how these rows are put together. Now, there's a real easy way for me to check, do I need to know this sort of stuff? Go back and actually read what is 1B, what is 1C. We aren't limited to just looking at 1A until we solve it. Look at the whole question. Sometimes it gives you direction. So B, what is the 19th integer that appears in the 21st row? Yeah, this is sort of needing me to better understand how this works. And, you know, explain how you got your answer. Well, it's the written contest. We should be doing that for everything. And then C part, determine the row and the position in that row where the number 1001 occurs. Okay, this is also some pretty important information, I would say. And if we can understand where the kth odd integer goes, we'll be set. So this is why I'm developing this theory. I am going to change this from n to r for row, just because we're now also going to start talking about, well, where do things appear in the row? Okay. So the kth odd integer appears in row r if this is the case. And if k minus r minus 1 over 2 is equal to, we'll call it p for position, then the kth odd is in position p in the rth row. Okay? And you could explain this a little better, I suppose, but I think pictures would suffice. You know, we want the 8th one. K equals 8. Well, 8 minus 6 is equal to 2. So second position, 4th row. This all it's working out. And I understand how this array is completely put together. So if I want the pth position in the rth row, I can use this formula. So add more sentences if you feel it needs more explanation, but there it is, and this is going to give me everything. So 25th odd is 49. And we can even start calculating. So 1, 2, 3, 4, 5, 6, 7, 8. R minus 1 over 2. You'll get 1, 3, 6, 10, 15, 21, 28. Well, we don't need to keep going. So 25th odd is in the 7th row. Why? Well, remember what we talked about. Okay. 25 is bigger than 21, but not bigger than 28. So he's got to be somewhere in here in the 7th row. In fact, he is specifically 1, 2, 3, 4th from the left in this row. Yeah. So that's some nice stuff there. Okay. So then we want, what is the 19th integer that appears in the 21st row? Explain how you got your answer. Well, just better explain how we got this formula here. So I would say something like there are 20 times 20 plus 1. 21 times 21 minus 1 over 2 numbers in the first 20 rows. So kth odd appears in and we'll even switch it to R to better explain our formula, because I didn't really explain the formula the best. So it appears in the pth position from the left if k is equal to p plus r times r minus 1 over 2, since the row fills from left to right. Okay, well, we need, so k is going to be equal to 19th position and 21st row. So 19, this will be 21 minus 1 is 20 over 2 is 10, so plus 2 10, so that's going to be 229. So it's the 229th odd. So the number is going to be equal to 2k minus 1, because all we have is k, so it's the 229th odd. 2 times 229 minus 1, that's going to be 4, 5, 8 minus 1, so that's going to be 457. 457 is the 19th one from the left in the 21st row. Okay. Determine the row and position in that row where the number 1001 occurs. Okay. 1001 is the kth odd, where 1001 is equal to 2k minus 1. So 2k is 1002. And that tells me that k is going to be 501. Okay. So 501 is equal to p plus r times r minus 1 over 2. And, this gets weird. How do I solve for p and r? Okay, I don't have my triangular numbers memorized that high. Well, let's multiply by 2. 1002 is 2p plus r times r minus 1. 1002 is equal to 2p plus r squared minus r. So r squared minus r is equal to 2, or not equal to 2p, but plus 2p minus 1002 has got to be equal to 0. I've got a quadratic here. I think if I try and start solving for it, knowing that p is going to have to be less than r, something might work out. So r is equal to negative b plus or minus square root of b squared minus 4ac all over 2. So r is equal to 1 plus or minus square root of 1 minus, so it'll be 4008, so this will be 4009 minus 8p all over 2. This isn't exactly becoming easy to work with. I'm wondering if there's a better way. I seem to recall that there is a formula that does the thing that I want it to do, which is find r here. Can't for the life of me figure out what it is. And that's just based off my knowledge of triangular numbers. This is turning out to be, like, I don't usually have to pause on question 1 on Hypatia. This is not boding well for this year. I worry that it's going to be particularly difficult. But maybe I'm just not thinking about it the right way. I don't know. What if P were 0? Well, P has to be, P is, no, not 0, but P is between 1 and R. So, where do we go from there? What if I just ignore this P? So ignoring P, we can approximate R. So R is equal to 1 plus, well, who are we kidding? It's going to be the plus 1. 4009 over 2, and this is something I can at least get a little bit of a handle on. So 4009, so the square root of 4009. 63 plus 1 over 2. So, it's approximately 32.15. So we'll try R is equal to 32. Okay. So if R is equal to 32, then 501 is P plus 32, 32 minus 1 over 2, so that's going to be 16 times 30. So P plus 16 times 31. Well, what's 16 times 31? So that's P plus 496, so P is going to be equal to 5. Alright, so that approximation worked out great. So 1001 is in the 32nd row and is positioned 5 from the left. So that'll be 101. Before it'll be 999, 997, 995, 993, and 991 should be the first guy up here. Now, I could double check this by saying, well, 991, how do I get that? 991 is times 991 plus 1 divided by 2 is 496, which I just saw is R equal to 32. So it's going to be the end of the 31st row. All right, so that worked out. Give myself a nice green check because I feel like that one went on a little too long. I feel like I didn't justify the pattern here enough, but you had to really quickly justify that, or you had to really quickly work out that pattern to do these other ones. And this just seems like a weirdly hard question right off the bat. I don't know. What are your thoughts on it? And did you guys have a faster way to do it? One that you feel a little more confident about? Because I didn't quite like how that one worked out. It doesn't bode well. Maybe the rest of the 2006 will be nice. It'll be a breeze. Or maybe it'll just be the worst Hypatia I've ever written. I don't know. We're going to find out. I will see you guys for question number 2 in the next video. And, yeah, that's it. So thank you guys for watching, and I'll see you there.